Hello everyone, myself Sujan. Today I am going to perform determination of composition of mixtures of liquid using viscometer. To perform this experiment, we will be using Ostwald's viscometer. So this is Ostwald's viscometer. The viscometer has two bulbs, one attached to a capillary tube. This is the capillary tube portion, and a U-tube below it, and the other to the other arm of the U-tube, but at a lower level than the capillary tube. Before going to the experimental details, let me explain what is viscosity. Viscosity is a measure of fluid's resistance to flow. Basically, it measures resistance to flow arising due to the internal friction between the fluid layers as they slip past one another when fluid flows. The viscosity also depends on temperature. Viscosity of a liquid decreases with increasing temperature. The SI unit of viscosity is Poisson. Now I am going to explain how to perform this experiment. To perform this experiment, we will prepare 4 different solutions of ethylene glycol: 2.5%, 5%, 7.5% and 10%. You can also prepare more than 4 solutions, but in this case we have prepared 4 solutions. And this is distilled water, which will be used as reference. The glassware we are going to use in these experiments are specific gravity bottle, measuring cylinder, beaker, volumetric flask, pipette and stopwatch. First, we will pipette out 10 ml of water . Into the lower bulb of the viscometer. Now I will suck it up to the other bulb, basically the upper bulb, to a point above this mark. So as you can see the mark here. Then we will release it and start the stopwatch as the meniscus crosses this mark. So as soon as it crosses this mark, we will be starting the stopwatch. And we will note the time taken to flow this from this mark to this meniscus mark. So I will stop the watch as soon as it crosses this below mark. And we will note down the time taken to cross this mark. Similarly, we will repeat this experiment for water 3 times and we will take the average. Similarly, we will perform the experiment for the other 4 solutions, each 3 times for each solution, and take the average. And finally, by using Poisson's equation, we will calculate the viscosity for each 4 solution. Since the water is reference here, we already know the viscosity for water. As you can see in the Poisson's equation, to calculate the viscosity, we have to calculate the density of the liquids. To calculate the density of the liquid, basically to measure the density of the liquid, we will be using specific gravity bottle. First, we have to weigh out the empty bottle using the weighing machine, weighing balance. Then we will fill the specific gravity bottle with the respective liquid and weigh it out. This will give the weight of the liquid, and since the bottle we are using is 25 ml, so you know the volume of the liquid. So this will give the density of the respective liquid. So from this we will be using Poiseuille's equation to calculate the viscosity. Now, as you can see in the observation and calculation table on your screen, the first column is for concentration, second is for density that we have already measured, third is for time of flow, then fourth is the average time of flow for each liquid, and the last one is the eta that will be calculated using the Poiseuille's equation I explained just before. Finally, we will plot viscosity against concentration of the liquid, and so from this plot the concentration of or composition of unknown solution can be found by extrapolating or interpolating the graph. Thank you.